projected climate change leading to increased rainfall. The 1915 flood that I mentioned earlier does remain the extreme high water level, and that's the governing design for this bridge. Metro Vancouver, the sewerage area, as was mentioned, it is a combined sewer system, which is gradually being separated. And so on the one hand, they see, well, once it's separated, it might actually have more capacity for the higher flows that are projected. But on the other hand, as it's being designed over the course of the next few years, that they should take into account any additional information they can get from the climate change projections, which do show increased rainfall. The components of the system vary from 25 to 100-year design lives, and as the design life is increased, where a component has a higher design life, that's where you need to be taking a more serious look at the climate change impacts. For components that have a relatively short design life, there's more opportunity to monitor and maintain the systems and replace them based on more up-to-date information when it comes time for that component to be replaced. The Northwest Territories, a very specific type of system was looked at. Of course, permafrost is the issue across our north, and in more areas that are typically have permafrost, or those areas are decreasing in range, particularly as you go west. It's increased warming as you go west across to north. What they do typically in those areas to what they're trying to do to protect the foundations is separate the structure from the permafrost soil, so you don't get the structure warming up the soil and softening the soil, and they're losing capacity of the foundation, as shown in the top photograph. And the thermosiphons are one mechanical system that's used to do this, to prevent warming of the foundation. So what's important here is we want to know about the ground temperature. And of course, they do know that's going to increase, and it's increasing at a rate to the north where the design of new thermosiphon foundations today could be impacted in the next few years. So that's one area of Canada where you can see a real immediate need for good information. And again, very few 1 or 2 degrees temperature difference in your design value is going to potentially lead to failure of these systems. In Ottawa, 3 federal buildings were looked at, and again, it's more around the increased temperature for longer periods of time in the summer, impacting or increasing the load on the mechanical systems, as well as the increased rainfall, potentially threatening or deteriorating the drainage systems. One thing they need the foundations in general, whether it's bridges or buildings, they need to consider is the capacity of the foundations, again, buildings in the north more so, but here, we're locating them in a floodplain, prioritizing those buildings that are located in more vulnerable locations. And for some structures, potentially, because of the temperature variations changing, we're getting, as we heard earlier, more rain on snow events, which is leading actually to increased load on the structures. There is a potential for structural failure, potentially, although it was not found to be the case in these buildings. So just to summarize the vulnerabilities that came out of these particular studies in generalizations, water treatment facilities can be sensitive. Of course, there's a water supply issue on the drought side, and the operations, the staffing of the facilities, and the emergency preparedness that would need to be in place for that. Wastewater treatment facilities, again, are sensitive, and both to the changes in influent as well as on the operations side. Roads are generally robust, but it's a very site-specific situation. So it's really all about foundation and slope stability, foundation weaknesses, whether if the rivers on which they're located, for instance, if they're prone to scour or prone to slope instability, and that can be exacerbated by increased rainfall and in combination with snow and ice, and the river regime can change as a result. Buildings, generally adaptive. Many of the components of the buildings, through ongoing monitoring and maintenance, you can adapt them on a more gradual component by component basis. Some of the key aspects to look, of course, at are the roofing systems, the membranes, the envelopes, coastal areas and permafrost regions. The coastal areas, of course, the sea level rise in combination with either increased rainfall or extreme storm events, and the permafrost regions, which are very sensitive to even small changes in temperature. So the key considerations we need to think about are what are the structures, how are they designed, how are they constructed, what are the serviceability situations. Also, is the structure already in a vulnerable condition? Much of the infrastructure across North America, certainly in bridges, is already vulnerable for other reasons. Perhaps it's poor maintenance, perhaps it's just aging infrastructure. So now your infrastructure already compromised may potentially see an additional load on the system. The design life, as I mentioned earlier, whether it's a short design life or a long design life, will affect how you take climate change into consideration. The geography or geology, whether it's in the floodplain or river crossings, whether your soils are already inherently susceptible to instability, will force you to take a closer look at those structures. Maintenance and rehabilitation, are there good programs in place? Is rehabilitation done on a regular basis? Are there good monitoring systems? Is your infrastructure inherently better taken care of? And the climate, both the trends, and that comes information coming from the global and regional models, as well as the extreme and unpredictable events, and very different ways to be able to predict those. So going forward, we need to do some more things to move forward with the adaptation. We do work at a very local level. So we need, for structures where we assess that we do need to look at climate change impacts, we'll have to look at very fine grid resolution of regional model, and that's still evolving. As I mentioned earlier, it's a 45-kilometer grid now, but they're moving to even a finer resolution, and that will give more precise site-specific information. Indirect effects could actually be quite critical. Groundwater level changes, slope instability. What would help is to have regional trends mapped, and then a closer look in combination or sequencing of events. For example, in the Quesnel Bridge a few years ago, Edmonton had 24 hours of intense or steady rain, followed by 1 hour very extreme rainfall, and in effect it shut down all bridges except the Quesnel Bridge due to the road surface flooding. We also need to look at our design codes, the design data. We look to our building codes, to our bridge codes, et cetera, for key climatic design data, and we found, in fact, that some of that data had not been updated for quite some time. So independently of our specific codes, the climatic data, which is used by all codes reference, needs to be kept up to date as much as possible, to a much greater level it is now. And we need some way of assessing the level of confidence we have in the predictions, and what is the range of uncertainty in them. We need to identify the regions and typologies that are most sensitive to climate change and focus our attention there. The permafrost regions, as mentioned, the coastal areas, and also we need more work done around the hydrology, which will help us understand the slope stability, the river behavior, and these that affect the foundation of our infrastructure. That's where the catastrophic failures can occur. And more information, or a database information potentially of extreme events, and also learning from other jurisdictions that have already been experiencing higher temperatures, are already experiencing extreme storms, and have either emergency preparedness that can deal with that, or design their infrastructure to accommodate that. So learning from other jurisdictions. Going forward then, existing and new structures. Generally, it should be and can be generally pretty robust and resilient if properly designed, properly constructed, and properly maintained. Many vulnerabilities can be managed through maintenance and rehab and upgrading activities. So in the natural cycles of those processes happening, taking into account climate change is not incrementally that difficult thing to do. Again, climate loads are only one of several factors and are not necessarily going to govern the design. It gives the assurance of taking into account as complete a picture as possible. Prioritizing by design life, and planning needs to become longer term, because it's over the longer term that you begin to see significant changes in the climatic data that begin to impact, perhaps affect your design. It's important we need to be able to identify the critical infrastructure and focus our attention there first. So an infrastructure inventory by the owners, both at the federal, provincial, and municipal level, would be helpful. We need to prioritize based on considering human health and safety issues, whether they're lifeline structures, what damage can we live with, and that's where the economics comes into it. The impact of land use planning, I think that was already alluded to as well, but planning so you minimize your impacts at the outset, and taking advantage of natural cycles to accommodate any additional changes from climate change. And then the last bullet there, review local design guidelines and operations procedures. We have our national codes, which I already mentioned, that need to be looked at and kept up to date in terms of climate information. But practitioners also rely on very local information, local guidelines, and that's where the owners of the actual infrastructure can ensure that those are being reviewed on a regular basis and updated to include climate change considerations. So that brings me to the end of the presentation. The studies, each of the studies, there's a full report in great detail that's available at PIVC's website. Currently, they're there now, and as well as a lot of more information on what PIVC is doing to look at adaptation of infrastructure in Canada. Okay, thank you.